Hi, this is Tim, and today we're going to go through the timer instructions in Rslogix 500. That includes the TON, the TOF, and the RTO instruction. A few things before we get started. We're going to move fast through actually creating a program, adding the instructions, because we have videos on those already. So I'll put links to all those in the description. Also remember, you have a pause button if we're going a little too fast, and we have an article that takes a deep dive into each one of these instructions. So be sure to click the link in the description to it. We're going to be using our basic trainer, which is still wired, for our getting started guide. And we're going to use our selector switch to start our timer. We're going to use these lights to figure out exactly what all this does. In Rslogix 500, we're just going to create a new program. And we'll just call it timer. And this is a 1763 Micrologix 1100 Series B. So we'll create that. Then we're going to use switch 1 to start our timer. So we're going to add a rung, and we'll do an XIC. Switch 1 is wired to I:0/4. And we'll just call that switch 1. And then we're going to put a TON instruction. So you have these tabs here, and over here, timer and counter. We'll click that, and then there is our TON. And we're just going to use the first one. So the timers are T4:0. And we'll just call this our timer. So a little bit about the time base. You have 1 second, 1/100th of a second, and 1/1000th of a second. So timers can count up to 32,767 units. That's a 16-bit signed integer, and that's the maximum value of it. If you have it at a 1 second time base, that means you can count to 32,767 seconds, which is roughly 546 minutes or 9 hours. So if you go to the 100ths time base, you're going to get greater accuracy on your timer, because obviously it's 100th of a second, but the amount of time you can time will be less. You'll be able to time for 327.67 seconds, which is roughly 5.5 minutes or like 100th of an hour. Then finally you have the thousandths of a second time base, which is extremely precise, but obviously has the least amount of time counting capability at 32.767 seconds, or about a half a minute. And I don't know, something in an hour that's super small. What time base you should use depends on, one, how long you need to time for, and also how accurate the timing needs to be. So for us, we're going to split it right down the middle. We're going to use the hundredths of a time base, because really we're more interested in how exactly does this work and what do all the other bits in it do. All right, and really that's all you need to get your timer going. Now over here you see you have an EN and a DN bit. There's also another hidden bit called the TT bit. And I really don't know why AB hid this bit, but it's really important early on that you realize that they have. So if we open up our T4 data table, let's just stretch it out a little bit so we can see it all. You can see right here, there is our EN bit, here is our TT bit, and there's our DN bit. We also see our time base right there, and we see a PRE, which is our preset. This is the value that we want our timer to go to. And then we have an accumulated value. This is how much the timer has actually timed. Now we're going to figure out, what do these 3 bits mean? We're going to add those in. So we're going to add another rung. Let's go back to our user tab. We'll add a rung, and we're going to use the XIC, and we're going to go for T4:0.EN. And we just won't put it. Now here's an interesting thing. If you don't put a description in, you saw it where it popped up there for a description. If you don't, it'll use its parent's description, which we made timer. Probably should have been a little more original with that, but I didn't think to at the time. Let's turn on our green light when it's enabled. So we're going to use an OTE instruction, and that is going to be O:0/0. And that is our green light. All right, now we're going to copy this rung and just paste it just like it is, because the only thing we're going to change here is we're going to make this the TT bit. So if I highlight the EN on this instruction, I can type TT. Again, we're not going to worry about a description because it's going to take its parent's description. And now let's take this and make it 1, which is our yellow light. So yellow light. And then let's paste it one more time, because now we're going to use the DN and number 2, which will be our red light. Okay, so now you might need to take a moment to pause, depending on if you kept up with this. I mean, hit the pause button, make sure you get all this in. Also want to thank our Patreon subscribers who helped make this video possible. If you want to learn more about being a Patreon subscriber, see the links in the description. All right, so we're gonna hit the verify button, and now we're ready to download our program, except I forgot one thing. I created a new program, but I have my Ethernet port configured on this 1100. As you can see here, we are connecting over Ethernet. So we are going to need to go into our channel configuration, and we're gonna go to channel 1. And we wanna disable boot P. And the same as in all these lessons, we're gonna use 192.168.1.10 with a subnet of 255.255.255.0. Why am I using this? Just for consistency. So there's nothing special about 192.168.1.10. It's just what we've used in all of them. And now we are ready to download. So we're going to go to System Communications, and I'm going to use the Ethernet IP driver to download it. Now I have a video on how to do all this, so I'm not going to go through it. I'll put a link to it in the description. We're just going to download, switch to program mode, and now we're going to go back to run mode and go online. Now, one thing I told you earlier is don't put a description in these. Well, here's why. Okay, so timer is kind of generic. If we wanted to change this description right here, and let's just put learning about timers. Not only did it change it right here, it also changed it down here in our bit instruction. So that's the advantage letting the child element use the parent description, is you change it one place and it'll change it all of them. Now the catch to that is if I right click this one and edit description, you can see it doesn't have anything. Now if I put timer enable, now it's not connected to that. We see it's timer enabled, but I don't have that easy association between this enable here and this timer here. So I like to leave the child elements without descriptions. It's not a hardcore rule, it's just something that makes it easier on me. Let's see if we can zoom out on this. Let's see if we can actually, let's hide our standard toolbar, let's hide our online, and let's hide our tabbed instructions. Let's see if we can stretch this down a little bit. And now, actually, so we can get all we can out of this. And now let's go to view, and let me see if I can zoom out just so we can see all of this. Oh, we're almost there. Let's go one more time. All right, there you go. Now we can see everything going on with this program right now. All right, so now we're online, we're ready. You can see the whole screen. One thing I did forget is I forgot to put a preset value in. Probably to describe this, we'll need about 60 seconds. One, I can't just go to the preset and hit 60 because it's 60 units of your time base. That is 60 1/100ths of a second or 6/10ths of a second. To get 60 seconds, I need to put 6,000 here, or 6,000 1/100ths of a second, which is 60 seconds or 1 minute. All right, so let's take a deep dive through these 4 rungs before we even enable our switch. From our previous video, the XIC instruction is going to say go look for a 1. Where? An I:0.0/4. We go over here, we have a 0, so it's false. And the most important thing to remember is that false instructions do something. As we learned in our bit instruction video, an OTE, if it's true, it goes right to 1. If it's false, it goes right to 0. Well, in this case, the timer instruction does things also. So when a TON is false, it's going to go right as 0 to the accumulated, the enable bit, the TT bit, and the done bit. It does that every time it comes around and scans this program. Now also, there's nothing magically somewhere else that is doing this. This instruction right here is what does this every time. So now we're looking at our EN bit. The EN bit simply says that the instructions preceding the timer are true. So right now the instructions preceding our TON are false, so it's going to be false. For the TT bit, it says that we're enabled, but our accumulated value is less than our preset. And for our done bit, it's almost the same thing as the TT. It says that we're enabled, but our accumulated is greater than our preset. Let's turn switch 1 on. We're going to see right away the accumulated values running up a lot of numbers. Well, those are hundredths of a second, and we can see right there our enable bit to the right of the instruction is true. Just like we talked just a second ago, our instructions preceding the timer are true, so that means our enable is true. Now down here we can also see it lit up. Well, an XIC instruction, whether it's looking at an input, an output, an internal bit, or a timer, does the exact same thing. It says go look for 1. Where? In T4:0.en. And there you can see we have a 1. And that's why we're indicating green right here, which turns on our green light here. Now our TT bit saying that we're enabled and our accumulated value is less than our preset, which right now it is. So we've got a 1, we have a yellow light, and right about now, bam, you're going to see the yellow light go off and the red light goes on. That's because our accumulated value became greater than or equal to our preset. So at that moment, we're enabled, but our accumulated is no longer less than our preset, so our TT bit is now 0. You can look over here and we can see it's 0. This is looking for a 1, so that's why the yellow light went out. At the exact same time, the done bit came on, and the reason was now we're enabled, but our accumulated value is greater than or equal to our preset. And so our red light came on. You may need to play with that a little bit. If you do, let's just switch this down to say 200. This can be 2 seconds. Now we switch it off. You can see immediately our accumulated value went to 0, and our 3 bits, the EN, the TT, and the done bit went to 0. We switch it on, 2 seconds, and they're done. So play with that several times so you can make sure you understand how the EN, the TT, and the done bit are related. Now let's go through the TOF instruction. Now we haven't really gone through what happens when we're doing online edits, but we have done it several times. So just follow me on this. We're going to have a video coming up really soon that really describes online edits. But we're going to highlight this first rung, and then we're going to hit the start rung edits. And then if we just double click on the TON part of the instruction, we can bring it up and we can change that to a TOF. And bam, we're done. This is now a TOF, because whether you're using a TON, a TOF, or an RTO, they all use the exact same data structure. So we're going to just click this Accept Current Rung Edits button, and then we're going to test these edits. And we're going to assemble these edits. And now we're going to look at it as a TOF. So let's switch our switch off. And yeah, you saw really quickly all of a sudden there were some lights on and there's some lights off. And that's what I love about the TOF instruction. It is one of the best instructions for describing that things do happen when an instruction is false. Let's bring the preset up to 6,000 so we can talk about this. And then let's switch 1 on. So what is happening right now? The TOF that is true will write a 0 to the accumulated value, a 1 to an enable, a 0 to the TT, and a 1 to the DN bit. But notice our timer is not timing. That's because the TOF instruction times when it is false, not when it's true. Okay, so now we'll switch 1 off, which is going to make our instruction false. And first we can see that our accumulated value starts going up. This is not a countdown timer. It still accumulates up. And our enable bit is going to be false, because mainly our enable bit says the instructions preceding our TOF are true. They're not, so it is false. So our timer timing when the TOF is false says the preset is less than the accumulated. Also, the DN bit, when the TOF is false, says the preset is less than the accumulated. So we have a few seconds left here, and we're going to see the TT and DN bit do the exact same thing when the TOF is false. And there you go. So now we're going to switch 1 back on and see what it does actually. Accumulated value went to 0. The difference between the TT and the DN bit is when the TOF is true. Right now the TT bit is false, as we're not timing, but the DN bit is true. So the TT bit will only be on a TOF when the TOF is false and the accumulated is less than the preset. Whereas the done bit is true again when the TOF is false and the accumulated is less than the preset, but also when the TOF is true. That one's not very easy to explain. It's a lot easier to see here. So again, let's drop down our preset to about 2 seconds. Let's just look at it. And you can see the difference. All right, so now there's still one more type of timer, and that is the RTO, Retentive Timer On. So again, let's edit this rung. Let's change our TOF to an RTO. That is our Retentive Timer On, and that's all we need to do. We're going to accept that, test, and assemble those edits. Now we have a setup for an RTO. Again, let's change our preset to 60. That way we can talk about what's going on. Now, unlike the others where we kind of explained and then we exercised it, let's just try this one out first and see what happens. So we still have, or probably you still have, a 200 in your accumulated value from the TOF. So if we switch one on, you can notice it started timing at 200. All right, now we're at about 800. We switch. Oh, wow! I got this. Now that was not programmatic. I did manage to stop that at exactly 800 seconds. Now we switch it back on. You can see it starts timing again where it left off. So this is a great way to do, like, say, runtime monitoring. Say you need to monitor how many hours are on a motor, or you know, maybe production data. How much time did this machine actually get used in 8 hours? This is a great application for this. But what exactly is happening here? Well, the RTO, for all practical purposes, is exactly the same as a TON, except when it's false, it does not set the accumulated value to 0. So it'll set the EN to 0, it'll set the TT to 0, and it will set the DN to 0. But it doesn't set the accumulated value to 0. So every time that you switch it on, it's enabled. The timer timing is 1 because our accumulated is less than our preset, and our done is off because our accumulated is not greater than our preset. Switch it off, it's going to stop. It's going to do exact same as the TON, except it will not reset that accumulated value. Now this time we're going to let it time on up. Now, something to be thinking about while we're waiting on this last 25 seconds is, I've told you that the timer instruction, everything about it is enclosed in instructions. So how does it keep track of time? You have 10 seconds to think about that. And there you go. We're still enabled because the instructions preceding our timer are enabled. Our TT is now off because our accumulated value is greater than or equal to our preset. And our done bit is on because our accumulated value is greater than or equal to our preset. Now, we switch this off and it doesn't reset. Turn it back on. So here's where it gets a little tricky. It's like, how do we do something about this? Well, now we need to learn about another instruction called the reset instruction. So if we go down here to the end, we're going to add another rung. Let me get my instruction palette back up just so we can see. And try not to use the way I've got it here, but I have my screen as large as I can so you can see. We're going to look at I:0/0, and that is our green button. And then we are going to do a reset instruction. And so that is right here. And we're going to reset T4:0. So this is going to reset. Now, what does a reset instruction do? It's going to set the accumulated value to 0. It's going to set the EN to 0, the TT to 0, and the DN to 0. So again, we'll accept that, test that, and assemble that. And one thing I just realized is you can't see both these rungs at the same time, and I want you to be able to see this. So I am actually going to drag this rung up here. You don't have to do that if you can happen to see it all on the screen, but it's good to be able to see this. So the moment that I hit this green button here, you're going to be able to see this accumulated value go to 0, and this done bit will go off. And bam, there you go. Now our timer is ready to go again. Quick side note is this reset actually works with the TOF and the TON instructions. And there are times that you may want to reset it externally instead of using the instructions preceding it to reset it. Okay, I hope this video has been helpful, and really exercise with this. Get to know the difference between the TON, TOF, and RTO bits, because I hear all types of crazy things and crazy ideas about how they work, and I hear rules that you shouldn't use the TOF because it's unpredictable and all types of things. Everything in a PLC is predictable. During that 10-second pause, I did ask you, how exactly does the timer actually keep track of time? Because I've told you that everything that has to do with that timer is contained in the instruction, but there wasn't anything there to actually track time. I think it's a little too much in the weeds for this video, because I think this video is probably quite long and there's quite a bit of content that I really want you to absorb on this. So in the next video, we're gonna kind of take a little bit of a look at really what exactly makes a timer time, and really mainly just prove that there's nothing magical somewhere else in the PLC that makes all this happen. Till next time. Hi, this is Tim.
And this is Amber of TW Controls.
We run the automation store.
Be sure to subscribe for more great videos.
And like this video and comment on what you would like to see next.
Visit our website where we offer a full line of PLCs, simulators, control panels, PLC trainers, and more.